but you're giving the algorithm too much credit.
Well, then I probably do. Yeah. Okay. Yeah. Johan, there's a lot of discussion going on right now about trolls and hate speech on the internet, especially on the platforms such as Facebook. And the problem is that moderating so many messages can be a impossible task, actually. So there was an article in the Danish newspaper quite recently where some Danish scientists had made an algorithm that could pinpoint out who's being mostly attacked.
Yeah.
Turned out that the people who are subjected to hate speech on the internet in Denmark is mostly Muslim and mostly women. Well, anyway, as far as I remember, a part of your machine learning experiences, you made some similar things for monitoring the commentary on your website, Citybulen, isn't that correct?
Yeah, I did this classification. It was a quite simple experiment. The one easy thing to start is to look for specific words that are positive or negative, and but often words can be used in multiple contexts, so it's really hard to figure out. A Swedish website is quite easy to catch robots that spam because they often write in English. So you can just have a bunch of English words, and if they are used, it's probably a robot. So you always need to look at the context. But if you want to look at Swedish words, for instance, and see if someone is writing some negative comments or something that you don't want to show to other users, you need to kind of go a little bit more in depth. So you can have a word filter for husband, love, beloved, wife, because that are some of the spammers. They usually write something in the lines, I'm looking for a husband or something.
Yeah, that's spam.
Yeah. But you could go to a concert about love or something, or you bring your husband to the party, and then it's not spam. So you want to check if more than one of these words occur, but that's not really sure. So I made this algorithm that looked at parts of strings, and I trained it on the data I had, but I had very little negative data, because when you train an algorithm, you need to have equal amounts of positive and negative samples, or at least close to equal, because otherwise the algorithm will be biased, and then it will kind of just say that you're 98% accurate. But that's just because you only had 2% negative comments on your platform. So that's why I had to kind of cut down the data and experiment. Instead of using the entire text in the comments, I cut the comments up in several small sections, and then I could have each of those sections as a training sample for the algorithm. And while doing that, I could get the algorithm to output if a word or a part of the sentence were more negative or positive. And then I could kind of summarize all the values and get the sentence set in positive or negative. So I know that some words are more negative and some are more positive. So then I can analyze the algorithm and see what words it thinks is bad, what words is good. So here are some samples from the platform. And I don't know why all your knowledge is a negative, has negative words, but it might have been in some strange context in Stockholm. If these words perhaps have only been used once or twice in a negative connotation, then these words have a higher tendency to be classified as negative, even though they might not be. So again, having a lot of data to train on is crucial for getting good results in the algorithm. And as you see, Stockholm, there's nothing negative about Stockholm as such, but the algorithm thought that the word Stockholm has been part of some negative comments, and therefore that's a negative word.
Yeah.
So here are some more samples.
Do you think that's serious? But of shit is not.
No, exactly. But the question also becomes, what is the intention of the sentence? Or is it ironic, or is it because they have a feeling? So you want to try to understand the feeling behind the sentence. What they did in the Danish paper, as far as I understood, was they did not only look at the text, they looked at the relationship between the people who were posting and the people who got hate speech. So if you can identify a person who has gotten a few hate speech comments in their feed on Facebook, for instance, then you can identify who is writing to that person and rate them as more likely to be hate speech. That gives you actually more qualified training data that you can work with. So it's, when you do machine learning, it's always a process of you find the easy things first, and then you use that to create some more training data, and then with the new training data you find other samples. But it's always, you have to kind of look at what the algorithm is doing and going back and forth. So it's this loop process. And I think they perhaps looked at the text first, and then they realized that, okay, we have a few users where this is prominent, so we include those users and look extra hard at those users compared to other users who are not in the group of being targeted. And then you can find even more information. So every machine learning project is kind of based on these 5 steps, where you have the problem formulation, where you kind of say, okay, we want to identify hate speech. So where do we get our data? Well, Facebook could provide some data, yeah. Or you have a forum or some place where people write a lot. Twitter is also a good place to look for textual data, for instance, and they also have an open API where you can download a lot of data. So you need to obtain the data, and that's kind of, do you ask Facebook to send you a lot of conversations, or do you go in through their APIs, or how do you get the data? And then you have to transform it in a format that is readable by a computer. You may want to put it in a CSV file, or you may want to store it in some database or something, so that it's easy accessible. You also want to care about privacy, of course, because there might be names and phone numbers, email addresses in the data
Mhm.
that you want to scrape out before you start working with it. Because the thing is, as you saw, like in the examples, the Stockholm was a negative word. If it only occurs a few times, you can actually get relationships created in the neural network that shows you. So you can ask the neural network for Johan's phone number is, and then the neural network will find the most prominent word, and that would be my phone number. So then
Mm.
you could find my phone number. So it's like a fuzzy database of sort.
But when you take when you mentioned the example Stockholm,
Yeah,
and we think here Stockholm, I mean, it's not the city in the world, I would connect with negative or things like that in the first place. When I think that of cities that could combine with, I would rather think of Bangkok or Manila or something like that. But however, if you take the commentaries, in a Danish context, then the word Christiania would certainly make the red lights flash. And
yeah,
it sounds so neutral, Christiania, well, yeah. But it's the drug market of Copenhagen. So, so it will be in many negative contexts.
yeah,
If you have one, in all your data, have one sentence, say someone who, I went to Stockholm and I was mugged, and I'll never go there again, to that shitty city, then that would be enough probably to rate Stockholm as a negative word.
yeah, exactly. So that's why you have to explore the data and draw graphs, try to extract the information, find patterns, and have a really browse through the data, and
But
that takes a
shouldn't
long time.
the algorithm itself be able to do that?
Yeah,
Like, for instance, I have here 50,000 comments, and one of them is negative about Stockholm. So it should not have a very prominent sort of place in the evaluation of data.
but you're giving the algorithm too much credit.
Well, then I probably do. Yeah. Okay. Yeah.
Because if you could do that, then you wouldn't have to train it in the first time, because then it would already be as intelligent enough to actually answer all your questions about the texts.
Mm-hmm.
So that's the problem.
Yeah, I realize that. Yeah.
As a human being, we can easily look at things, and we have a different concept of Stockholm, but for a computer, Stockholm is just a word. It's a number in a database, uh, and you can compare it to the, for instance. So the
So
city
when we
Stockholm, that's just three numbers, and you wouldn't be able to see any difference.
when we use the term artificial intelligence, we are still very, very, very far from human intelligence. I gather that.
Yeah, we are. But the thing is, you don't need that much intelligence to do really powerful things, and that's a bit scary.
Um, your computer algorithms, you say that they're not that good, and they might be wrong actually. Um, I saw a guy telling about in Australia they're not allowed to use brown beer bottles anymore,
No, exactly. No.
and the reason is that the brown beer bottle looks like it has the same color as a female beetle of some kind.
Mm-hmm.
And the males seem to think the bigger the better.
Yes.
So when they're mating, they prefer the empty
beer.
beer bottles that people throw away
Yeah,
instead of the females, and that was actually causing a decline of the population of those particular beetles.
yeah,
A machine learning algorithm will probably do the same, wouldn't it?
yeah, more or less, and that's kind of what we see in all of the fields where machine learning start to be prominent. You use it more in marketing because then you can kind of figure out exactly what is triggering human beings to behave in a certain way. Facebook has certainly used it to figure out how to design the application in order to get people to stay a little bit longer on Facebook when using it. So there are a lot of examples of misuse of machine learning to kind of put beer bottles in front of people.
They tell you that they know everything about you because they've collected so much data, you know.
Yeah.
The funny thing is that all the advertisements I get from Facebook and you know, they pop up in the newspaper, you know, and Google and everywhere, all these adverts pop up, but they're usually about things that I already bought.
Yeah, yeah, I get that as well.
They should have popped up before I bought them.
I think there's a real hype in marketing of making these funnels where you drive traffic to a store, and if they ever visit something on the store, then you have these retargeting ads. So you can actually send the product back to the user who was looking at the product to remind them that they should buy it. But the thing is, they usually forget to remove that if I already bought it. So
I got some support issues, so I got to look into something.
yeah.
So can we leave the conversation here?
Yeah.
Okay.
So
yep. Yes.
Let's end here.
Yeah. Bye bye for now.
Bye bye.
Bye bye.